let's have the headset.
Okay, here you are.
Do you read me, Ted?
Roger.
Your safety belt fastened?
Roger.
Do you have oxygen flow?
Roger.
Are you ready for takeoff?
I'm ready, then.
29 Juliet, ground. Are you ready for calibration? Stand by, I'll turn things on.
Hook up, please, Dick.
Okay, open. Close.
The National Center for Atmospheric Research presents 29er Juliet. In the skies above Colorado, two cloud physicists are on the way to their laboratory. They are studying the processes that cause rain or snow or hail. For that, they must reach into the very clouds themselves. Their workbench is a glider or sailplane, engineless, lightweight, instrumented for research.
Ted, you see the cloud at 10 o'clock? I think I want to head for that. 07 X-ray, turn left, heading 360.
Roger, 360.
07 X-ray, stay on this heading. Ted, you want to do a measurement of the humidity now?
Affirmative, then.
Once released, the sailplane will ride the sky's natural air currents, maneuvering thousands of meters upwards to penetrate the clouds.
.07 X-ray, 29er Juliet is about to release. 29er Juliet is releasing now.
Juliet, 29 Juliet, ground.
29er Juliet ground, 29er Juliet.
Vim, I would appreciate a calibration.
Roger for calibration.
Okay, 0 volt.
Play. 0 volt. Now.
.5 volts, please.
5 volt. Now. 5 volt, please. 5 volt. Now.
Data, please.
Back to data. Now.
Looks like a good calibration, then. What's your present position?
7 miles northeast of Estes Park at flight level 250.
Climbing on the rising air currents is called soaring. A skilled pilot can stay aloft for hours, sometimes soaring to heights above 10,000 meters. In winter months, air moving across mountain barriers sets up a series of waves on the leeward side. Along the tops of these waves can be found a special sort of cloud, continuously forming on one side and dissipating on the other, although its shape remains stable for long periods at a time. For this reason, the lee wave cloud is an ideal object for study, and a sailplane lifted by the waves to great altitudes is an ideal tool.
Altitude is 2-3,000. There is a big cirrus cloud overhead with a well-defined edge on the western side, indicating it's a wave cloud. And there is a smooth-looking wave cloud east of us, a little lower than we are. We plan to enter this. Entering the updraft again. The lift is 2 meters per second, heading 080. Heading back for the cloud now. Dive brakes open. Dive brakes closed now. We are close to the wave cloud. Ted, are you ready for the particle camera?
Roger.
Entering the wave cloud now.
During the summer, cumulus clouds towering above the plains become spawning grounds for thunderstorms, hail, and tornadoes. These convective storms are now under study by the National Hail Research Experiment, a joint effort of several universities and other agencies. With its unique flight capabilities, the Explorer sailplane is lending valuable support to the hail research program. In hot weather, a sailplane uses another source of lift, narrow chimneys of rising air called thermals. Catching the edge of a thermal, the sailplane can spiral upwards, gaining altitude sometimes faster than 5 meters a second.
We have released here underneath a big cumulus cloud. We are going up 1.5 meters per second. I'm in the left turn. The lift seems to be stronger on the eastern side of the turn, sometimes 2.5 meters per second. It goes up to well over 10,000 feet. There's no problem in staying up. Go straight and level, heading east. Go back in the left-hand turn. Denver Center, sailplane 909 Juliet, over.
Sailplane 9929 Juliet, Denver Center, go ahead.
29 Juliet is at 14,000, squawking 1400, 6 miles northeast of Fort Morgan. Request IFR clearance for cruising below flight level 200 until 2200, over.
Sailplane 29 Juliet, squawk 4000 and ident.
For a 10-mile radius around Fort Morgan Airport.
Sailplane 29 Juliet is cleared to fly a 10-mile radius at Fort Morgan Airport. Cruise at or below flight level 200 and radar contact.
Thank you. Juliet ground, 29 Juliet.
29 Juliet, ground. Go ahead, please.
I'm now planning to head for the cloud at 2 o'clock, which is about 7 miles to the northeast of Fort Morgan, in the same position that we found a cloud like that the day before yesterday.
Roger, thank you.
In the study of cloud physics, a sailplane has advantages over powered aircraft. Instead of passing quickly through a cloud updraft, it can sense and remain in the core of the updraft, where the most important physical processes occur. Having no propellers or turbines, it causes minimal disturbance to the cloud, and there is no exhaust to contaminate measurements of the cloud's properties. It is only in recent times that man has had wings enough to reach and study clouds. But the dream of soaring, eagle-like and free above the earth, is ancient. He was the first to try and the first to fall. But the myth of Icarus inspired centuries of imagination. There shall be wings, said Leonardo, who had studied of birds. He called his design an ornithopter. It never left the pages of his notebooks. But there were others who would fly, however briefly. Jean Lebris, a retired sea captain, fashioned his wings after the albatross. His maiden voyage ended in a crash. He broke a leg and never flew again. The real pioneers of gliding flight were men like Octave Chanute, whose feats inspired the Wright brothers, and Otto Lilienthal, who made over 2,000 leaps before he finally gave his life. And on the sands of Kitty Hawk, 3 years before their historic powered flight, Wilbur and Orville were learning to glide. But the discovery of thermal soaring was still 20 years away, and it was not until the 30s that the modern sailplane began to evolve, sophisticated, durable, more than a match for any hawk or eagle. Even among sailplanes, the Explorer is special in the scope of scientific instruments it carries. It is the first to be used for detailed studies of cloud physics. The Explorer is owned by the National Oceanic and Atmospheric Administration. Scientists of the National Center for Atmospheric Research fly it and have developed the instruments aboard. These instruments take continuous measurements of such things as temperature, pressure, humidity, and the vertical speeds of updrafts and downdrafts.
This looks pretty good over here.
A unique camera system has been installed to photograph microscopic water and ice particles in their natural state of suspension during flight through the clouds.
Okay. There we go.
Particles are also measured electronically by an instrument called an electrostatic disdrometer, which records the distribution of particle sizes. In-flight data and observations are transmitted to a mobile ground station where they are recorded for later analysis.
Compass reads 065. I'm correcting now. The altitude is 17,420. The humidiometer switch is on logarithmic. The humidiometer window is open and has been open.
Very good. Did you measure your outside temperature yet?
Spot checks are occasionally made to calibrate the continuous temperature and humidity measurements.
Temperature 10.0. Wet bulb temperature 7.5 in optical housing shadow.
Fine, thank you.
Going straight and level on heading 270. Heading for the part of the cloud that has the highest development. Direction indicator on now. Turn indicator, attitude indicator on now. Vacuum pump on now. Probe heat on now. We are entering cloud now. Juliet ground, 29 Juliet. Are you getting distrometer data?
Yes, you are getting distrometer data. Looks very good. Very good.
Can hear some grauwpel on the canopy. Windscreen is wet. Ice is melting off the windscreen.
Start particle camera.
In addition to particle photography, the pilot can record the impressions of cloud droplets on die-coated slides.
I'm shooting slide gun now.
Then I was watching the ice as we went through that section of cloud, watching the ice against the optical housing background, and it looked like it was a very high concentration there. We should have really gotten some good frames with the particle camera on that path.
It's getting quite turbulent here, and in an average we are not going up. It's very bright here, we can see the sun. Straight and level, heading 270. Leaving cloud now. Humidiometer window open. Attitude, turn indicator off. Vacuum pump off. Probe heat off now. There is a rain shaft visible about 5 miles southeast. It's a lightning strike, 12 o'clock. Heading is 360. A vertical lightning discharge at 3 o'clock. The storm appears to be moving in the direction of the airport. Maybe we better go down before the service winds pick up.
Right, Vim, I've got us down for 4.5 hours off tow, so let's head back.
Roger. 29 Juliet ground, 29 Juliet. We are leaving the area now. 29 Juliet met, 29 Juliet for wind check.
29er Juliet, surface winds are 040 degrees at 5.
Thank you. Boulder Unicom, sailplane 29er Juliet, request your airport advisory.
29er Juliet, this is Boulder Unicom. Winds are light and variable. Active runway is 08.
Thank you. Boulder traffic, sailplane 29er Juliet entering downwind for runway 08.
Okay. You have that other wing